4, polynomial division. So the learning targets for today's lesson are we're going to learn how to use synthetic division to divide polynomials, and then a couple of applications of synthetic division. We're going to learn how to use synthetic division to evaluate a polynomial using the remainder theorem, and then another application of synthetic division is using the factor theorem to solve polynomial equations. So before we start, let's talk about division in general. So when we're dividing whole numbers, there are multiple ways we can express this. So this means 7 divided by 3. And I can't reduce this, so this is called an improper fraction. But there are things called mixed numbers, which show, okay, if I take 7 and I divide it 3 ways, how many times does 3 go into 7? Well, we know 3 goes into 3, and 3 goes into 6, and then there's 1 left over. So 3 goes into 7 2 times, because it takes 3 plus 3 is 6, with 1 left over. So we say this equals 2, remainder 1. Sometimes written as 2R1. Another way we could write this would be 2 and 1/3. That is a mixed number because there were 2 3's built into 6, or into 7, with 1 left over. So 2 and 1/3. And 2 and 1/3 technically is the same thing as 2 plus 1/3. 2 plus 1/3. So this is an important concept that we'll revisit later on. Okay, so that's whole numbers. What about factorable polynomials? So one thing we've done a lot this year is simplifying and reducing polynomial expressions based on their factors. So if we think, okay, the numerator has this factor. This is a factorable trinomial. Remember, we're looking for 2 numbers that multiply together to get 3 and add to get 4. So 3 and 1 work. So we say x plus 3 times x plus 1. So that's what the numerator simplifies to if we factor it. And now with this denominator, I have a binomial down here with a common factor of 2. So I can take out the 2, I can factor out the 2, and I'm left with x plus 3. And notice, now that we have it factored, we have x plus 3 times x plus 1 over 2 times x plus 3. Any factors that are the same in the top and bottom, in the numerator and denominator, can reduce to 1. So essentially they cancel out. So you're just left with x plus 1 over 2 as your final answer for this. But again, we haven't actually done any division with this. We're just simply breaking it up into its factors and then reducing things that end up reducing. But what about tougher to factor or non-factorable polynomials? This trinomial up here is non-factorable. This binomial down here is already completely factored. It's non-factorable. Both of these are prime polynomials. So there's got to be something we can do to divide prime polynomials. And there is. So how do we divide prime polynomials? We use what's called synthetic division. Synthetic division. There is something called long division that exists as well, but this lesson we're going to focus on synthetic division. So under what conditions can I use synthetic division to divide polynomials? Well, it has to do with the denominator. The denominator must be linear. And by linear, I mean it has to look like mx plus b, where it's something times x plus something. Very often, m is 1. So some examples would be like x plus 2, x minus 4, x plus 6. You could even have a coefficient with the x, 2x plus 1. It makes it a little trickier when you do that, but it still works. 3x minus 4, and so on. Any sort of linear factor. Now, you could even have just an x. You can have just an x where you do x plus 0. It's kind of like divided by x plus 0. So this is how we would perform synthetic division with this example from the other page. So you start, there's two important components. You have to be able to recognize, okay, what are the coefficients of the numerator polynomial. And then what is the 0 that corresponds with this factor? So if you were to set this equal to 0, x minus 3 equal to 0, and solve it, add 3, you get x equals 3. So 3 is the 0 that goes with this factor. The coefficients here are 1, 5, and 2. So you start, when you're performing synthetic division, we're essentially performing this operation, x squared plus 5x plus 2 divided by x minus 3. You start by putting the 0 of the denominator right there. So notice how, since it was minus 3, it became 3. It's essentially just the opposite of this when we have a linear factor with a coefficient of 1. So we have a 3 that goes right here due to this, the opposite of this term. And then you put the coefficients kind of spread out. So 1, then a 5, then a 2 up top. We're creating this division problem where we're going to be doing some adding and some multiplying. And what you do is you bring down this 1, so it goes right there. And now you're going to do 3 times 1. So you're going to multiply. So 3 times 1. And the result of that's going to go here. So that equals 3 times 1 is 3. And now we're going to add these. So we add 5 plus 3 is 8. And now we're going to multiply again. 3 times 8. Put the result right there. That would be 24. And then we add again. 24 plus 2. Adding those two together, you get 26. And the way this works, remember, these were coefficients of this original polynomial. This was the x squared term, this was the x term, and this was the constant term. You can think of it like the x to the 0 was right constant. So the x squared x, then constant. What these are the results. This right here is your remainder. That's your remainder. Kind of like our remainder on this page when we divided 7 by 3, our remainder was 1. So this number is the remainder. What these two numbers are the resulting polynomial when we divide. So what always happens is, since our original, the leading term was x squared, for the new one, the result of our division, this power is going to go down by 1. So this is going to be the x term, and this is going to be the constant term. So our answer is 1x plus 8, and then the way we're going to do it is we're going to say plus the remainder, which was 26, over what we divided by, which was x minus 3. And that is our final answer for that synthetic division problem. All right, we're going to do one more example, then I'm going to have you guys try one. Okay, so we're going to divide using synthetic division. So remember, x minus 4, we need to know what the 0 is that goes with this. When this is just a 1 leading coefficient, we know it's just going to be the opposite of this. If I set x minus 4 equal to 0, add 4, I get x equals 4. So that's the 0. That's what goes in the box out to the side when we're doing synthetic division. I'm going to do this down here, actually. So 4 goes here. And then my coefficients go up here. So the leading coefficient is 4. You might think the second coefficient is x squared, but it's not. Because notice how we had a 4 here, there's a missing x cubed term. If this term represents x to the 4th, even if there is no x cubed term, this second number here has to represent x cubed. Then x squared, then x, then our constant term, the term with no x's. So the x cubed term, since there isn't one, that would be 0. The x squared term, the coefficient is negative 4. Notice the x term. Oh, there is no x term. So we make that 0. And then our constant term is 6. So now we have it all set up. Now we're going to perform synthetic division. So we start by bringing down this leading term, 4, and we're going to take these two and multiply. So multiply, and put the result right here, equals 16. Now we add these two. So 0 plus 16 is 16. And we perform our multiplication again. 4 times 16 now, multiply. The result goes right there. 4 times 16 is 16 times 2 again, that'd be 64. And you can use a 4-function calculator for this test. You can do simple multiplication. There will be no graphing allowed on this test. 64, negative 4 plus 64 would be 60, so we're adding. And now we perform our division again, or our multiplication again. 4 times 60 would be 240. Again, we add down, add these two, put the result down here. Again, it's 240. One last multiplication. 4 times 240 is 960. Add those two together, you get 966. Box that off, because remember, that is your remainder. That's your remainder. Okay, so these numbers, remember, are the coefficients of my solution. The coefficients of my solution. I'm going to write down under here, so I'm going to erase some of those lines, make myself some room. So since this original term was the x to the fourth, the quartic term, x to the fourth, this one is one less than that, so that's going to be x to the third. So we say 4x to the third. This is positive 16, so plus 16x squared, and they just go down by 1 each time, the powers. Plus 60x, plus 240, plus our remainder. Remember, it's always the remainder over the denominator of the original. So we say plus the remainder, 966, over what we divided by, which was x minus 4. And that is the result of your synthetic division. All right, now I want you to try this one. So pause the video and unpause when you're ready to watch me complete it. Okay, so you're ready to watch me complete it. Hopefully you gave this one a try. Now, performing synthetic division, remember we start with finding the 0 of our denominator. So x plus 3 equals 0, x equals negative 3. So negative 3 is the number that goes in our box out to the side. And then the coefficients get written out up here. So our first coefficient is 1. Remember, that's the x to the fourth coefficient. Second coefficient would be the x to the third coefficient, of which there isn't one. So then we put a 0 for that one. Then we've got our x squared coefficient, our x coefficient, and our constant term coefficient. So x squared term is negative 10, x term is negative 2, and constant term is 4. All right, now we're ready to go. So we start by bringing down this 1, multiplying 1 times negative 3, or negative 3 times 1, and getting negative 3. Add these two together. 0 plus negative 3 is negative 3. Do the same thing again. Negative 3. Negative 3 times negative 3 is 9. Add these two together. Negative 10 plus 9 is negative 1. Multiply again. Negative 3 times negative 1, which is 3. Add these two together. Get 1. One last time. Negative 3 times 1 is negative 3. And add those two together to get your remainder, which is 1. Remember, this is our remainder right here. So now we bring down these numbers, and these are the coefficients of our result, the quotient of these two. So we bring down the 1. Remember, this was x to the 4, so this one's going to be x to the third. So we say 1x to the third. You don't have to write that one. I'm going to, though. Next one's x squared, so minus 3x squared, minus 1x, plus 1, plus whatever the remainder is, which is 1, over what we divided by, x plus 3. All right, so use this to check your work. Awesome job. All right. Next topic, remainder theorem. So if some function f of x is divided by x minus c, so some number c, then the remainder is the same thing as what f of c would have been. All right, how or why might this be useful? So let's think about this problem right here. So we have some very bare of a function here. A quintic function, fifth degree. If I asked you to evaluate f of 3, think about it for a second what you would do to find f of 3. So if you're thinking you would plug everything in, then you're right. You'd plug 3 in for all the x's, which I've set up right here. Using function evaluation, that's how we do this in past lessons. This is what you would do. I don't even know what 3 to the 5th is. Let me think for a second. 27, 81, 243, I think it's 3 to the 4th. No, 340, I think 343. But essentially, this is a long and arduous process. And there is a better way to do this. It's by using the remainder theorem. Using the remainder theorem, we can, instead of just evaluating this, which is a pain in the neck at minimum, you can instead of evaluating f of 3, we can divide by x minus 3. So take our original function, divide it by x minus 3, and the remainder will equal f of 3. So the remainder will equal f of 3. So let's do it. So, well, we know we're dividing by x minus 3, so 3, the 0 of x minus 3 is going to go here. Put all our coefficients, 1, negative 5, 3, 2, negative 6, and 1. Okay, let's do our thing here. All right, synthetic division. Bring down our 1. Multiply 3 times 1 to get 3. So remember, 3 times 1. Multiply those two together, put the result right there. We're going to do that every time the number goes down here. Negative 5 times 3, or it's negative 5 plus 3, negative 2. 3 times negative 2 is negative 6. Add those two together. 3 plus negative 6 is negative 3. 3 times negative 3 is negative 9. 2 plus negative 9 is negative 7. 3 times negative 7 is negative 21. Notice we've kept our numbers very nice and small by doing this compared to these. That would have been huge. Negative 6 minus 21, we got negative 27. And then lastly, 3 times negative 27, we got negative 81. So 1 plus negative 81, this is our remainder, negative 80. Now, what are we trying to find here? The remainder is equal to f of 3. That's what we're looking for. Look at that. There's the remainder. So f of 3 equals negative 80. Boom. Done. Much easier than all this mess. So that's how the remainder theorem can be useful. All right, I'm going to do this one, and I'm going to have you try one. So again, use the remainder theorem to find f of negative 4. Well, essentially, the remainder theorem states that if we're trying to find f of negative 4, we got to take this and divide by x minus negative 4. Well, that turns into x plus 4. And when we divide by x plus 4, the 0 of this would just be back to negative 4 again. Set that equal to 0 and solved, you get x equals negative 4. So essentially, when you're using the remainder theorem, whatever you're evaluating, this is the number that goes in the box at the beginning. So that's a quick way to remember that. So f of negative 4 goes in here. And we're looking for whatever our remainder ends up being, this number right here, whatever this is going to be equal to f of negative 4. All right, let's set it up. So first one is 3, then I've got 4, then negative 5, and then 3. So first we bring down our leading coefficient. Now we multiply. 4 times negative 3. And every time we write a number down here, we're going to multiply it by negative 4 and put the result across from it. So negative 4 times 3 is negative 12. Add those two together, we get negative 8. Negative 4 times negative 8 is positive 32. Add those two together, we get 27. Negative 4 times negative 27 sorry, negative 4 times positive 27. Put it in your little calculator, and we get negative 108. Combine here, 3 plus negative 108 is negative 105. And look at that, there's our remainder. So f of negative 4 is equal to negative 105. And that, ladies and gentlemen, is how we use the remainder theorem to evaluate functions. All right, pause the video. So try this problem below, then unpause to see the solution. Okay, so hopefully you've done the problem and you're ready to see the solution. Let's work it out. So we're using the remainder theorem to find f of 2. So you may have remembered from my previous description that whatever this number is, that's the number that goes inside the box at the beginning of our remainder theorem. Because remember, we're dividing this whole thing by x minus 2, which when we find the 0 of that leads us right back to 2. The shortcut of which was this is the number that's always going to go in for that. And we're looking for the remainder when we do this. That's what's going to equal f of 2. The remainder when we divide our original function by x minus 2. So coefficients, leading coefficient 1, then negative 4, then 5, then 3. Notice no missing coefficients here, so it doesn't need to worry about any zeros in the middle. No hidden terms. Now we go ahead. We're going to be looking for this number right here. This is going to be our answer. Bring down our 1. 2 times 1 is 2. Negative 4 plus 2 is negative 2. 2 times negative 2 is negative 4. Add those two together. We get 1. 2 times 1 is 2. 3 plus 2 is 5. Boom, there's our answer. F of 2 equals 5. Done and done. Okay. Factor theorem. Factor theorem. If f of c equals 0, then x minus c is a factor of f of x. All right, this is a useful tool because essentially what it does, it allows us to say if we know what a factor is, then we can divide by x minus that factor, or if we know what value of x is, if we know what something is a 0 of a certain function, we can divide our original function by x minus that to reduce it, to help us solve equations. So for example, this particular equation right here, if we're trying to solve it, it's tough because we don't have a method that allows us to solve this. We don't really know, there's no formula, there's nothing we can do to solve this besides putting it in a calculator, which is not allowed for this unit. So, but what I did tell you is that 3 is a 0 of this particular function. So if 3 is a 0, that means, so just like that's kind of like saying f of 3 equals 0 for this particular function. That's what it means by 0. When you plug 3 in, you would get 0. So that means x minus 3 must be a factor. So x minus 3 must be a factor. And if it's a factor, that means we can divide by it and then simplify this into something that we can actually solve. So we're going to divide this by x minus 3 using synthetic division. So we're going to take this, divide by x minus 3. And remember, there was the 0 of this is just 3. So again, we're just using this number in our box here. And we're going to divide. So 2, negative 3, these are just coefficients. Negative 11 and 6. Here we go, performing synthetic division. 2 comes down, 3 times 2 is 6. Negative 3 plus 6 is 3. 3 times 3 is 9. Adding those two, combining like terms, negative 2. 3 times negative 2 is negative 6. Oh yes, 0. 0 is the remainder. That's the first time that's happened. That makes sense because that means that essentially we could have if we knew we could factor out an x minus 3, we could have done so. So essentially what we've just found is that x minus 3 times, or let's write it right here, x minus 3, because we divided by that, times 2x squared, remember this was the x cubed term, so this one became x squared, 2x squared plus 3x minus 2 is equal to this original function. and we're trying to set this equal to 0. All right, now I can work with this. We were told that 3 was a 0, but again, we know 3 is a 0 based on the fact that x minus 3 we divided by and we got 0. So x equals 3. How would we solve something like this? Well, we were going to use the quadratic formula. The quadratic formula will always work. Those of you that are interested, that can use the divide and slide method, can try that. I'm going to use the quadratic formula for this one. So remember, a is this, a is 2, b is 3, and c is negative 2. And we say x is equal to negative b, that's negative 3, plus or minus the square root of b squared, 3 squared, minus 4 times a, 2, times c, negative 2, all over 2 times a, 2 times 2. Okay. Remember, this is called the quadratic formula. You can look that up, quadratic formula, if you forgot it. So negative 3 plus or minus the square root. And remember, we're just solving the equation. That's what we're doing. We rewrote the equation as this as a result of 3 being a 0, and now we're solving the equation. So negative 3 plus or minus 9 minus plus 32. 4 times 2 is 8 times 2, just kidding, not 32. That'd be 16. 9 plus 16 all over 4. 25. So the square root of 25 is 5. I got negative 3 plus or minus 5 all over 4. So my two answers are negative 3 plus 5 over 4 and negative 3 minus 5 over 4. That's negative 8 over 4, so that would be negative 2. So negative 2 is one of our solutions. And the other one would be 2 over 4, which is 1/2. So we've got 1/2, 2, and 3 are my three solutions here. X equals all of those. And that's all, folks. All right. All right. Pause the video, attempt the problem below, and unpause when you are ready to check your answer. This is our last problem, so don't lose hope. All right. Hopefully you have attempted the problem and are ready to keep it going. Now, if you got stuck at some point, feel free to pause when you get your question answered and then keep trying your problem. Don't just try it once and then give up and just watch me do the whole thing. All right. So we're solving this equation given that negative 1 is a 0. All right. So whatever the 0 given was, that's what we're going to divide by with synthetic division. So remember, our factor theorem stated that if negative 1 is a 0, then that means x plus 1 must be a factor, which means I can divide by it and get a remainder of 0, which helps me out. All right, so I'm going to do negative 1, synthetic division, use my coefficients here, 15, 14, negative 3, negative 2. All right, dividing. And remember, my goal here is to reduce this down to a quadratic that I can use either the quadratic formula for or another factoring method. All right, so 15 comes down. Negative 1 times 15 is negative 15. Add these together, we get negative 1. Negative 1 times negative 1 is 1. Add those together, we get negative 2. Negative 1 times negative 2 is 2. Negative 2 plus 2 is 0, which we should have gotten. So we want a remainder of 0 when we're dividing by something that we know is a factor. Because remember, we're dividing this whole thing by x plus 1 when we are given the information that negative 1 was a 0. All right, so how do we interpret this? Well, we interpret this meaning that this original equation right here can be rewritten as, well, when we divided by x plus 1, we've put negative 1 here. So we know it's x plus 1 times our result, which remember, this was the x cubed term, then x squared, then x, then the constant term. So each one of these just goes down by 1 compared to those. So we got 15x squared minus 1x minus 2 equals 0. So we've just rewritten what I have boxed up here as this. And now we're ready to go with quadratic formula because we've got x equals negative 1 for our first answer. And then we can use the quadratic formula to solve this one. Or you could factor with divide and slide. I'm going to do this quadratic formula though. So quadratic formula, x is equal to negative b. So negative 1, so positive 1, plus or minus the square root of b squared, that's be negative 1 squared, minus 4 times 15, that's a, times c, which is negative 2, all over 2a, that's 2 times 15. So we got 1 plus or minus the square root of 1. Got 2 negative 2, that's going to turn positive. So plus 120 all over 30. So we've got 1 plus or minus the square root of 121 all over 30. And the square root of 121, that happens to be a perfect square, that's 11 squared. So we've got 1 plus or minus 11 all over 30. So I've got 1 plus 11 over 30, and 1 minus 11 over 30. So 12 over 30, which simplifies to, I could divide both of those by, what can I do, 6 over 15. I divide both by 6. So 2 over 5. 2 over 5. So 2/5 is one answer. And the other, we got negative 10 over 30. Divide both by 10, we get negative 1/3. So our three solutions are x equals negative 1, 2/5, and negative 1/3. And those are our three solutions to this one. Remember, negative 1 was included because this was a 0. We're still trying to solve the equation, so we still got to report that one. All right, great job. You've made it through lesson 2.4. Congratulations. Please email Mr. Saari if you have any questions, and great job.